Welcome to this explainer, where we're going to dive right into the fascinating everyday magic of an object that's probably sitting right under your hand at this very moment, the computer mouse. Today, we're exploring the precise mechanics of this essential tool, and we'll map out exactly how your physical movement in the real world turns into instant digital action on your screen.
So I want you to really think about this for a second. How exactly does a simple plastic puck control your computer screen? We use it for hours every single day, right? We totally take it for granted. But when you get down to it, how does moving this lightweight, basic little object across your desk actually translate to pixel-perfect actions on your display? How does the computer know exactly what you want to do?
Well, to answer that, we have to start with the foundational definition. A computer mouse is, at its core, an input device used to control the cursor on a computer screen. An input device is absolutely the crucial term here. It's your primary translator. It's the bridge between your human intention and the computer's digital execution.
Section 1. Anatomy of the mouse. Okay, so looking at the top of a standard mouse, you're basically interacting with three main parts: the left button, the right button, and the scroll wheel. This trio makes up the primary user interface, and it divides up our daily digital tasks with just incredible efficiency. The way these split the work is actually pretty brilliant when you think about it. The left button, that's your primary action driver. It's for selecting, dragging, opening. It's your absolute workhorse, the one we, furiously mash 100 times when a program unexpectedly freezes up. The right button, on the other hand, is your context key. It unlocks hidden menus and secondary options depending on exactly where you're hovering. So, simply put, left is for doing and right is for discovering.
And then, nestled right smack in the middle, we have the scroll wheel. As our source material highlights, you use this to smoothly navigate up and down on pages without having to drag a clunky scroll bar on the side of the screen. But what's super useful is its dual-purpose nature. You can actually press the scroll wheel down and click it exactly like a regular button, which gives you an entirely separate input right in the center of the device.
Section 2. How movement becomes digital. Now, if you flip that mouse over, you're going to see the real brains of the operation, the optical sensor. Located right there on the bottom, this sensor uses a light, usually either an LED or a high-precision laser, to actively track your movement. It's not just a glowing light to make the mouse look cool. It is an incredibly sophisticated piece of hardware intensely illuminating the surface of your desk.
Just check out this massive number, thousands. When you slide your mouse across a flat surface, that optical sensor is taking thousands of tiny pictures of that surface every single second. That is just a mind-blowing fact. It's operating like an ultra-high-speed microscopic camera, capturing frame after frame after frame in the literal blink of an eye. Okay, so wait. How does snapping a bunch of microscopic pictures move a digital arrow? Well, it happens in 5 lightning-fast steps. First, you move the mouse on a flat surface. Second, the sensor takes those thousands of pictures per second. Third, the hardware instantly compares those sequential pictures to each other to detect microscopic differences, calculating your exact direction and speed. Fourth, it packages that movement data and sends it to the computer. And finally, fifth, the computer translates that data to cursor motion. All of that computation, the picture taking, the comparison, it all happens in fractions of a millisecond.
Because this whole sensor process is just so incredibly fast, the reaction feels totally instantaneous to us. You move the mouse right, the cursor moves right. Move the mouse up, cursor goes up. You combine that precise movement with your buttons. Say you click the left button on a folder and bam, the folder's selected. Double-click and it instantly opens. The thousands of pictures and complex data transfers just completely disappear into the background, leaving you with this seamless, deeply intuitive experience.
Section 3. Wired versus wireless connectivity. So how does this hardware actually talk to your computer system? Basically, 2 main ways. You've got a wired mouse, which is directly connected by a physical USB cable. That guarantees a constant, uninterrupted stream of power and data. Or, conversely, you have a wireless mouse, which cuts the cord entirely. This uses either a Bluetooth connection or a small, dedicated USB receiver plugged into your machine to transmit all those rapid-fire data packets right through the air, giving you complete freedom of movement. Section 4. The simple definition. Our source material wraps this all up with a really fantastic summary. If you ever need the ultimate, bite-sized technical overview to explain this to someone, this is it.
A mouse is an input device used to control the cursor on a computer screen. It works by using an optical sensor to detect movement and sends that information to the computer. It has left and right buttons and a scroll wheel for performing different tasks. It perfectly encapsulates the entire technical overview we just walked through into one clean little paragraph. I want to leave you with this final thought. The next time you sit down at your desk, rest your hand on your mouse and make a simple click. Will you think about the thousands of microscopic pictures being taken every single second right under your palm? It really is a brilliant piece of engineering hiding in plain sight. Thank you so much for joining me for this explainer, and I hope you never look at your digital workspace the exact same way again.